What is going on YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 20, Problem 36, in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 20 is all about entropy and the second law of thermodynamics. And in Problem 36, we are talking about a heat pump, and we are asked to find how much heat is transferred to the room. And so we know that the efficiency of a Carnot engine is equal to 1 minus the heat of the lower temperature reservoir over the heat of the higher temperature reservoir. And that is equal to 1 minus temperature of the low reservoir over temperature of the high reservoir. And in this problem we're looking for how much heat is transferred to the room, and so we're looking for the QH. And so what we can do here is subtract 1 from both sides, and so that's just going to leave us with negative QL over QH is equal to negative TL over TH. And so now what we can do is we have a negative on both sides, so that cancels out, and then what we can do is multiply both sides by QH and divide both sides by TL, and that is going to give us QL over TL is equal to QH over TH. And now we can multiply both sides by TH to isolate QH, and so then QH is going to be equal to TH times QL over TL. And so in the problem we're asked what the heat released would be per joule of energy consumed. And so that means that the work done by this pump is 1 joule. And so work is equal to QH minus QL. And so what we can do is rearrange this for QL, and so we're going to add QL to both sides and subtract W from both sides, and that's going to leave us with QL is equal to QH minus W. And so now we can take that QL and plug it into here, and the reason why I did that is because in the problem we are given W, but we are not given QL. And so now we can make that substitution, and we'll have QH is equal to TH times QH minus W all over TL. And so now we can distribute TH over TL into both of these terms, and so we'll get QH is equal to TH QH over TL minus TH times W over TL. And so now we can move this term over to the other side, and that's going to give us QH minus TH over TL QH is equal to negative TH times W over TL. And then we can take out the QH, and that'll give QH times 1 minus TH over TL is equal to negative TH times W over TL. And then we can divide both sides by this term right here, and so then we can find that QH is equal to negative TH times W over TL, all of that over 1 minus TH over TL. And so in the problem we are given W, TH, and TL, so we have everything we need to solve this problem, but the temperatures given are in Celsius, and so we're going to want to convert those to Kelvin because the Kelvin scale is all positive numbers, and so that makes these ratios work out. And so what we're going to do is our TH is given as 17 degrees C, and to convert that to Kelvin we add 273.15, and so TH is going to be equal to 290.15 Kelvin, and then T low is going to be equal to negative 5 plus 273.15, and that is going to be equal to 268.15 K. And so now we have all the values that we need, and we can plug them right in. And so QH is equal to negative TH, so negative 290.15 K times 1 joule divided by TL, which is 268.15 K, and all of that divided by 1 minus TH, which is 290.15 K, over TL, which is 268.15 K. And then if you plug all of that into your calculator, you should find that QH, or the heat released to the room when this heat pump is working, per joule of work consumed is equal to 13.2 joules. And so that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.